Hello, hope you all are doing well. Today we'll be going over some QMS110 materials. More specifically, we'll be going over Chapter 1, Section 1.5 to 1.7, which covers radicals, the rules of radicals, and how to solve equations with radicals. Earlier in the chapter, we went over numbers and the types of numbers, where we learned that radicals are irrational numbers that don't have an exact decimal form. Today we'll be going more in depth to figure out what radicals really are. The simplest way to learn radicals is to consider it as the opposite of the exponent. So if the square root of 2 is equal to 4, therefore the radical of 4 is equal to 2. It's also important to remember that the number under the radical is called the radicand, and the number indicating the root being taken is called the order or the index of the radical. Sometimes you may see a radical sign with nothing written indicating the root or the index. In this case, it is considered to be a square root and an index of 2. Let's start with a simple example of solving a radical just to get a bit of a recap. So to solve a radical, the easiest way is to find numbers that make a perfect square. Here we have square root of 75, which can be split up into 25 times 3. Now we know that 25 is a perfect square of 5, therefore we can write it as 5 squared times 3, where 5 can be taken out of the radical sign to get 5 square root 3 as your final answer. Moving on, let's go over the basic rules of radicals. The very first rule shows that if the exponent inside the radical and the order are the same, then we can simplify the radical to get the number inside the radical as your final answer. Moving on to the second rule, if you have two radicals being multiplied by each other with the same index, in this case you can combine the radicals and have a simplified radical with the same index, and the numbers inside are being multiplied by each other. The third rule is about the division of two radicals with the same index. You can combine the radicals and have a single fraction under a single radical. The last rule is about a radical inside a radical. You can multiply the indices and get one simplified radical. You can also find a similar table on your QMS110 book, page 21. Now let's move on towards the addition and subtraction of radicals. It is important to remember that radicals must be similar to perform addition and subtraction. This implies that radicals must have the same order and the same radicand. Let's go over some examples together. Here we have 5 square root of 3 plus 6 square root of 3 minus square root of 2. In this case, the first two terms have the same radical of square root of 3. Therefore, they can be added together to get 11 square root of 3. The third term has a different number under the radical, therefore it cannot be subtracted and would just be written as is to the expression. And your final answer would be 11 square root of 3 minus square root of 2. Here we have another example of square root of 2 plus square root of 8. Why don't you try pausing the video and solving this on your own before we go over it together. So square root of 2 plus square root of 8. Here the radicands are not the same, therefore they cannot be added right away. However, if we expand 8 into 2 times 2 times 2, we can solve the equation further. We have simplified the square root of 8 to have similar radicands of square root of 2 before we went on to simplify the equation to get 3 square root of 2 as your final answer. We multiplied the 1 next to the empty square root of 2 sign and the 2 next to the other square root of 2 sign to get 3 plus 3 times square root of 2. Moving on to the multiplication of radicals. Remember that the product of two radicals can be combined when they have the same order. For example, here we have square root of 2 plus square root of 3. In this case, you can multiply the numbers inside the radical as they have the same index to get square root of 6. Moving on to another example, here we have the cube root of 2 multiplied by the cube root of 5. Why don't you try pausing the video and solving this on your own before we solve it together? You can also find this question on your QMS110 book, page 28. Here in this question, we have radicals with a different index. In this case, it's simpler if you change the radicals into fractional form. Here we changed the cube root of 2 into 2 raised to the power 1 over 3, and we changed the square root of 5 into 5 raised to the power 1 over 2. To solve it further, we do need to find the lowest common denominator. On the side over here, I have done the working to find the lowest common denominator of the two fractions. In this case, it is 6. Therefore, we multiply 1 over 3 by 2, and we multiply 1 over 2 by 3 to get 2 over 6 plus 3 over 6. In the next step, we have taken 1 over 6 common to have 2 squared multiplied by 5 cubed with 1 over 6 common. Simplifying it further, we got 4 times 125 to the whole root of 1 over 6. Which gives us 500 raised to the power of 1 over 6, which could then be converted into the rational form of the 6th root of 500. Now we will be moving on to the division of radicals. If a fraction has a radical in the denominator, we must rationalize the denominator to get rid of that radical sign. This is done by changing the middle sign of the denominator to find the conjugate. A conjugate is the same two-term expression but with the sign in the middle changed. So, for example, if you have 6 plus square root of 3, the conjugate would be 6 minus square root of 3. Let's try this example together. You can also find this example on your QMS110 book, page 29. In this case, the conjugate would be square root of 3 plus square root of 2. Therefore, we multiply the numerator and the denominator by the same number to get square root of 3 plus square root of 2 . We could then solve it further and multiply the two terms. So in the numerator, we now have square root of 3 plus square root of 2, and in the denominator, we have square root of 3 minus square root of 2 multiplied by square root of 3 plus square root of 2. To solve the denominator further, we would use the distributive theorem to multiply both terms. In this case, we would multiply square root of 3 by square root of 3 plus 2, and we would multiply negative square root of 2 by square root of 3 plus square root of 2. This would then give us square root of 3 plus square root of 2 divided by 3 plus square root of 6 minus square root of 6 minus 2. Also remember, when you are multiplying two radicals that have the same number under the radical sign, then we would just get the number under the radical sign. Therefore, if we are multiplying square root of 3 by square root of 3, the answer would just be 3. Simplifying this further, we have square root of 3 plus 2 in the numerator, and then we have 3 minus 2 in the denominator, which could be solved further as square root of 3 plus square root of 2 in the numerator and 1 in the denominator. We could also write it as square root of 3 plus square root of 2 as your final answer. In summary, we studied today about radicals, the rules of radicals, and how to solve equations with radicals, including addition, subtraction, multiplication, and division. For more practice, I would recommend going over the Chapter 1 section review questions. Also, don't forget to check out the ASC website for tip sheets and more. To keep up to date with support and programming, follow us on our social media. Thank you for watching this video.